Radiation of heat. All objects emit and absorb infrared or thermal radiation, which are electromagnetic waves, part of the electromagnetic spectrum. The higher the temperature, the more they will emit. If they are at a higher temperature than their surroundings, they will emit more than they absorb, and vice versa. Here we have two cans filled with hot water, one painted dull black, the other shiny silver. I'm going to represent the infrared radiation entering and leaving the cans with arrows. The dull black can has 16 arrows leaving it, whereas the shiny silver can has only 12 arrows leaving it. Black is a better emitter of infrared radiation than silver, so the dull black can would give off more radiation than the silver can. Now to show the radiation being absorbed by the cans. I've shown 6 arrows going into the dull black can and only 4 going into the shiny silver can, because black surfaces are also better absorbers of thermal radiation. So overall, the black can has a net loss of 10 arrows of radiation, the silver can a net loss of 8 arrows of radiation. In this case, the objects are hotter than their surroundings, so it is the emission of radiation that is important, and the dull black can is a better emitter of radiation, and so will cool quicker. Here we have the two cans again, but now filled with cold water. They're now colder than their surroundings. The dull black can will still be emitting radiation. Now it's emitting 6 arrows. The silver can, being a poorer emitter of radiation, is only emitting 4 arrows. The black can, however, is absorbing 14 arrows of radiation, being a good absorber of radiation. The silver can absorbing just 6 arrows of radiation. In this case, the cans are colder than their surroundings, so it is the absorption of infrared radiation that is important, and the dull black can is a better absorber of radiation, and so will heat up quicker. Now to look at a few situations where these properties are utilized. A heat sink might be attached to a component that gets hot, such as a computer chip. Its job is to absorb the heat energy from the computer chip and pass it on to the surroundings. It will be made out of aluminium, which is a good conductor of heat, so it will gain heat energy easily from the computer chip. It will be painted black, making it a good emitter of thermal radiation. It will also have many fins to give a large surface area and so maximize heat transfer. Metal teapots will stay hot for quite a long time, despite the metal being a good conductor of heat. This is because it has a shiny surface and so is a poor emitter of thermal radiation. It is not very good at passing its heat on to the surroundings. Polar bears have black skin, which allows them to absorb thermal radiation from the sun, gaining much needed warmth. Aircraft firefighters wear shiny metal suits to minimize their absorption of thermal radiation when fighting a fire.